Hi there. Welcome to my presentation on online tools that promote best practice in remote mathematical learning. A quick overview of this presentation. First, we're going to start out by looking at remote teaching in the past school year. I'll let you know some of the goals that I set out for both myself and my students for the school year. We're going to do a brief introduction to the tool Mathigon Polypad, which was what I found to best suit the needs of my students. I'd like to review pedagogy and best practice in the mathematics classroom, and then I'd like to finish with a story or a day in the life of my students in my mathematics class. So to begin, with remote teaching in 2020-2021, I was a grade 7 homeroom teacher where I had the opportunity to teach my grade 7s almost every subject area. As well, I was blessed with being able to teach the grade 8s their math as well. The students that I had in my classroom were those who had elected for remote learning for the entirety of the school year and were registered in our new online school. I had about 32 students in total, with some changes throughout the year, so never below 30 students and never really above 35 students. I did have a unique perspective this school year as I was reassigned from my mathematics facilitator position that I had held for the previous 3 years. This point of view allowed me to bring my knowledge and understanding of the Ontario curriculum, as well as my understanding of best practice, and really put that into play and really meet the needs of my students this school year. So in order to meet those needs of my students, I had to set goals for both myself and for them. I wanted to make sure that they had the opportunity to explore, reason, and manipulate, and really truly make sense of the math, even when they were learning online. I know that the Ontario curriculum says using tools and manipulatives many times in the intermediate grades, so I wanted to make sure that I was helping my students to always have the option to visualize and explore, and to do so with some digital tools. I found that Mathigon Polypad was really the answer to meeting this goal. It helped me to teach my students to make their thinking visible. So Mathigon Polypad is really an online whiteboard, but the thing that sets it apart is that it has similar manipulatives that you would see in a mathematics classroom. Some of the reasons why I really loved Mathigon Polypad were because of its easy integration for Google. Students could sign in easily, and I could post assignments to students in the Google Classroom with just a click. I also loved the teacher dashboard and viewing options. I could see my students' work in real time, which made everything just so much more meaningful for my students. I also love that Mathigon Polypad has the tagline, textbook of the future. This truly does ring true for me because students have the ability to really show their thinking and play with the math. If you're interested in Mathigon Polypad, I would suggest that you start on their website. They have so many great resources and professional development videos and webinars that you can learn so much from other teachers and from the experts. So on the Mathigon website, there is a For Teachers tab, and here you can find an overview, which lets you know that Mathigon Polypad is free to use and it is totally flexible and accessible to use in whatever way works for you and your students. There are previous webinars that have been recorded that you can have access to, and you can learn from those who have maybe had more time to explore Mathigon. There's also tutorials and ready-to-go lesson plans and activities for your students. When I think about teaching online, the first thing that came to mind was the pedagogical system. I knew that it was important to include the 4 cogs of the PED system in my learning and teaching every day. It was very important to first establish a non-threatening classroom environment for my students, and then also make sure that I had worthwhile mathematics tasks, classroom discourse where my students could really talk about their math, and then also that I had tools and representations and ways that students could show their thinking. I know that in face-to-face, good pedagogy includes the 3-part math lesson where students really get to explore and make sense of the math, but then they also have time to practice these new skills and concepts. I wanted to figure out a way to transfer this to remote learning. I needed to figure out very early on in the year, what does this look like? So we'll walk through what this actually looked like for my students. Overall, most days we went through a 4-part math lesson actually. So we did our regular 3 parts, the minds on, action, and consolidate, but then I always added in that practice piece as well. So students could really have that opportunity to show what they know and to really consolidate those skills that they just learned. In the Minds On, this is my space to make sure that I could create a safe, non-threatening environment, giving students the opportunity to activate prior knowledge and think about what they're already bringing to the table. In the action task, this is where I really wanted to make sure that I was using worthwhile tasks and giving students the opportunity to figure out what makes sense and why it makes sense. The consolidation portion of the lesson is really time for students to explain and discover. This is where the teacher can anticipate student responses, and using Mathigon Polypad, they can actually use the class view and they can see who answered using a variety of strategies, and maybe students could even explain and reach more peers that way. And then in terms of practice, the tools and representations that Mathigon Polypad provides allows students to show what they understand and prove their thinking. So what we'll do now is we'll go through a typical lesson and how I use Mathigon Polypad in each of those 4 parts of the lesson. So one lesson that I went through this school year with my students was area of a trapezoid. I wanted to make sure that I wasn't just telling my students the formula for area of a trapezoid, but they could make sense of why that formula makes sense and why it works to find the area of a trapezoid. So we first went through our lesson learning goal, where we knew that we were going to be trying to find some of the different properties of a trapezoid and why it makes sense to calculate the area of a trapezoid using the formula. The first thing we did was we went through a Minds On activity. So students were asked to create a trapezoid using 3 pattern blocks. They were going to figure out what is the area of that trapezoid if the unit of measure was 1 green triangle, and then what is the area of the trapezoid if the unit of measure is 1 blue parallelogram. I also had some shared slides for students that I gave them access to in the chat. So students were able to go to the pattern blocks that I gave them the link to, and they were able to share on a slide shared deck. So this was very simple in that this is all that it looked like. So I gave students a blank canvas with just some of the pattern blocks that they're used to seeing in a classroom. In order to access these tools, we can click on tiles in the top left corner, and we can click on geometry. So we've got all of these different polygons here. Now you'll notice that we've got the yellow hexagon, the green triangle, the red trapezoid, and the blue parallelogram. So those are similar to what students would see in the math classroom. Now they were asked to use 3 of those in order to make their parallelogram. Students could move these around and really manipulate until they found a parallelogram that really worked for them, a trapezoid that really worked for them. So this is just a quick way to show you just how easy it is to move these blocks around and snap them into place. And then students were able to either download the image or take a quick screenshot. Once students were finished making their trapezoid, they were able to share their work in our shared slideshow. So I removed students' names just for this presentation, but students each had their own section where they could quickly put in their picture of their trapezoid, and I could see if they really understood, number 1, what a trapezoid was, if they were following those directions to only use 3 pattern blocks, but then also if they were understanding the idea of area, and if the unit of measure was 1 green triangle or if the unit of measure was 1 blue triangle. And so you can see here that they could peek at each other's work. There was no such thing as cheating. There was no penalty for not exactly knowing what was going on, because this was just the Minds On. This was just activating prior knowledge. So they were really sharing their work, and this is where some students kind of caught themselves even and saying, oh, I forgot I was only supposed to use 3 pattern blocks, or oh, that's not actually a trapezoid. So it was really great for students to be able to write their work in and for them to see from each other what their trapezoids looked like. So it allowed for some flexibility and creativity for my students as well. Once we were done reviewing the Minds On task, we moved into the action part of our lesson. So this is directly from Math Up, which is the program that our school board uses for mathematics instruction from kindergarten to grade 8. So the action task from Math Up says here, the drawing below shows the dimensions of an airplane wing. Use the grid to estimate the area of the wing. Now, this would be very difficult to do online when I know that my students at home did not have access to grid paper and that I wasn't sure that they would actually measure this out properly. We could end up with some quite a variety of answers here. So I decided, let's use Mathigon Polypad. I make sure that I always review with students that they need to open up the link to Mathigon Polypad that I send to them. I ensure that they are signed in the top right corner. They save their own copy of their work, which means that I have access to viewing and I can see exactly what they're working on and how they're working on it. I ask them to, of course, complete their work and then click Save as they work, as it doesn't save automatically. So taking a look at what this looked like on Mathigon Polypad, I was easily able to mimic this on Polypad. So here we are with a grid background, which is one of the options on the right-hand side. So I could choose a grid. I have the exact same dimensions labeled here for students so that they could really start to play around with this. The nice thing about Mathigon is that they could actually select this polygon and they could cut it if they'd like to. They could copy it and make another one that looks the exact same. They can move it around if they'd like. But the nice thing is that students had access to really play with that tool. So in real time, students were working away at trying to figure out what is the area of this trapezoid when they don't know the formula just yet. So I anticipated that I'd have a few different responses from students. And I'm able to see student copies on the left-hand side here. So I could see already that some students were trying to duplicate that shape. Some had duplicated and flipped the trapezoid shape. Some were filling in that trapezoid and making it into a rectangle. And then some took that blank space and they found what is the area of the triangle of this blank space, and they subtracted that. So I could see in real time who was using what strategy, which really helped me in getting ready for the consolidation piece of this lesson. So this is just a quick example of one of my students' work. So this student decided to take that trapezoid and split it into 3 triangles. We were familiar with finding the area of a triangle, and so this student decided to try to split the shape up. The next student that I wanted to point out took that trapezoid and shaded in the 2 extra spaces here. We can see that this student didn't quite finish up their work, but I understood where they were coming from. And I think that even just the fact that they could show their thinking here showed me that they're on the right track to making sense of this math. And then the last student decided to do this here, where this student took the green trapezoid that I had given them and they duplicated that. So they copied it by pressing the plus sign, and they put a copy of it right underneath. We had already gone over the formula of a parallelogram in this school year. And so this student was very comfortable with trying to figure out what is the height and what is the width of that parallelogram. And they were able to find the area of a trapezoid. This also helped them to make sense of that formula. And this is what I was able to use for the consolidation piece. So in my prepared lesson, I did have 3 different strategies ready to go and anticipated what my students might have tried. So this is what the first student did try to do. She did try to split that trapezoid into 2 triangles and a rectangle, and then find the area of each and then add those together. But it was much more meaningful for my students to see that their peer had actually tried this strategy. The same thing, I did see that student who took the green trapezoid and then duplicated it and put the purple trapezoid below. But again, it's more meaningful knowing that one of their classmates had tried this strategy. And then this last strategy here of shading in those pieces there, finding the area of a rectangle and then subtracting those 2 triangles, the area of those 2 triangles to find just the trapezoid. When we consolidated this, and as we were going through kind of the classroom discourse and the conversation between what strategy seemed to make most sense, students seemed to really like the idea of using the 1 trapezoid, duplicating it, and just using the area of a parallelogram because they were comfortable with that. So that's what we went with our class, and we really did focus in on what did they need, what best suited their learning needs, and how do we make sense of this math. So once I did introduce the formula, students understood why it was half of a plus b times the height, or 2, the top and the bottom times the height. So they understood why it was half, because really we were taking those 2 trapezoids and making it into a parallelogram, but we only needed 1/2 of that parallelogram. The last part of this presentation is going through the practice and the review piece that my students were able to do in order to make sure that they really did understand why the formula for a trapezoid made sense, and so that they could really show that they understood that. So I did have students review a quick review page, but then we used Mathigon Polypad again for that practice. Each student was assigned this practice page. So this was found on Google Classroom, and students were able to see each of these different trapezoids. They saw the formula that we had just co-created and just discovered together, and they were able to use that formula to find the area of the trapezoid here right on Mathigon Polypad. If students didn't like to use the formula, they were very welcome to cut this shape up and, again, explore, manipulate, reason, and try to make sense of that math. So they were able to use any of the strategies that we had reviewed today, even though the one that most students did like was the duplicating and then halving of the parallelogram. But students had the opportunity to play with the math, to understand why it makes sense, and to show their thinking and really making their thinking visible. So Mathigon Polypad gave me the opportunity to see my students thinking, to make sure that they had a place where they could actually make the math look like math that they were used to doing in their workbooks. They had all of the tools that they would normally have accessible to them in a face-to-face classroom. This is where I do truly think that the 4 cogs of that pedagogical system came to light, that every one of the math lessons that we were able to work through, we made sure that students had a non-threatening classroom environment, worthwhile tasks, the tools and representations, which we really did discover here, and then also classroom discourse where they could discuss what made sense, why did it make sense, and who used what strategies. So I just want to say thank you for tuning into this presentation. If you have any questions whatsoever, please feel free to reach out. But I do strongly suggest that you look at Mathigon Polypad as a way to reach your students and give them the tools and representations that they need in order to show their thinking in a mathematics classroom, whether it's face-to-face or remote. Thank you.